Okay, you're live.
Okay, so this developer talk is about React component testing and how we are moving towards doing that in Mattermost. So just for a bit of context, the Mattermost web application is pretty large. Like we've got well over 300 components in there now. And it's using a sort of what we call a Flux-like architecture. So it's mostly Flux, but a bit messier for various kind of legacy reasons. And the current setup makes unit testing of components quite difficult because they all tend to call into the stores, and then that drags in a whole load of dependencies, and it becomes very difficult to test them. And while you could mock out the stores, it's a lot of work, and it's just not really practical doing all of that. However, we are moving towards using Redux in our web application. We've used it very successfully in the React Native mobile apps, so we're moving the web application over to that as well. And one of the nice things about moving to Redux is it tidies up the architecture of components a lot. So you end up, once a part of the app's been migrated to Redux, with an architecture more like a sort of controller component, which doesn't have a UI, and then below that in the hierarchy, a bunch of UI components which are pure. So they're getting all the data they need is being fed into them through their props, and not by them directly accessing stores. So what that means is you end up with most of your UI components being easy to isolate because they get their data from props alone. And it makes them a lot easier to test because effectively the props become the API, the kind of contract between that component and anything interacting with it. And because you've got that single point of interaction, it makes it much, much easier to test them because, well, putting the right props in should get the right results out. So from that point of view, we are concurrently, as well as moving over to Redux, looking at doing a lot more component testing. We have in our source code the basic framework for doing that. And we have the first few tests. And as we move more stuff over to Redux and tidy up more of the web app components, we will be getting a lot more of these tests. So just before I dive in and start talking through some tests, a little bit about the infrastructure for this. So we're using Jest, which is a test runner from Facebook. And it works much like most of the other test runners. Its main kind of unique feature is that it allows you to do snapshot testing. So you can save a known snapshot of something and then run tests that compare against that. And we're also using the enzyme library, which allows us to sort of shallow render the React components, meaning just render that component and not any of its child components, which makes unit testing them in isolation much more achievable. And a library called enzymes.json, which links those two together so you can snapshot test the shallow rendered components through enzyme. There's plenty of places you can read about how to set all this up. So I won't go into that now because it's already done in the Mattermost repository. So let's talk about some actual tests. On the screen, you can see there's a component. It's actually quite a simple component. I've chosen that deliberately because it's nice and easy to get started with. You can see it all on one screen. So we've got a single property, the children property, so the sub kind of HTML-like things you feed into it when you use that component. And all we're doing is rendering each child component with another HTML entity, this angle right bracket in between. So it's building up a header. All the children you send in, it renders one after the other with an angle bracket between them. So really simple. And there's one other thing to note about this component, which is the one property it's got, children, is optional. It's not a required component. So we can either not pass in any children or we can pass in some children. So we want to test that API. We want to unit test that to make sure that it's going to do what it should do, whether we pass in zero children or some children. So we write our two test cases here. So the first, we've got a test suite for the backstage header component. That's the name of the component. And the first test we say is, let's shallow render it with no children, so just the component on its own, simplest form, and then let's check that what's rendered matches a snapshot. And then the second test, only marginally more complicated. Let's give it a couple of child properties, and then again, shallow render it and check that matches the snapshot. Now, shallow rendering means it'll only render the components you pass in. So if instead of a div here, we passed in another React component, that would just appear as the React component. It wouldn't actually render it and work out what's inside that. It would just, let's say we passed in backstage header part. It would just render backstage header part in tags there. It wouldn't actually expand that, which is handy because we don't really want that. We want this to be isolated. So it's unit testing just the backstage header component. We don't want some change in a component far down the sort of tree to break a whole load of other tests when it's edited for some reason, because that's not the point. We're trying to test each component in isolation. So let's run these tests. So I'm just going to quickly do this. So we can run npm run test:watch, and what that does is it runs a test watcher which looks out for any changes being made to tests and reruns those tests. So you can leave that just ticking along. So we'll start that there. And it's determining which test suites to run. So it hasn't found any that have changed. So what I'm going to do is I'm just going to kind of artificially change this one and save it. A new line there. And now it's identified this test file as having changed, and it's run the tests, and we can see they've all passed. So the snapshots match the existing snapshots. Now, what about if we go into backstage header and change it? Let's, instead of having an angle right, let's have an angle left. There. So let's change that and save. And now we can see down in the console here, it's rerunning it. And oh, failed because we changed it. So the snapshot's no longer right. So if we look up here, first of all, we can see that the first test passed because there were no children, but the second test failed with children. And we can see a diff here of what was expected versus what was got. And we say, well, yeah, I changed that. That's how I expected it to change. That's fine. It's not a bug introduced accidentally. That's a deliberate change. So down here, we can press U to update the snapshots. So I'm going to do that. And now, without any manual editing of the snapshots, it's updated them. It's noted the fact that one snapshot updated, and now it's all passing again. So let's just have a look at the snapshot files. This is what they look like. It's basically just the rendered code. So you can see for the one with children, that's what the code that gets rendered looks like. And for the one without children, it looks like that. And these, you don't need to edit these manually. When you make a new test, it'll generate them on the first run. And then whenever you make subsequent changes, you can use the method I just showed you with the update to update those files. But you do need to check them into Git, because without them, the tests don't know what the known good state to compare against is. The test runner puts these in a folder called snapshots inside your wherever the test case is. So if we go down here, you can see that I've got my test is in tests, backstage components here, and then there's a __ snapshots __ folder, and in there is where the test snapshots are stored. Okay, so that's how we run the tests. That's a really simple component. Let's look at a slightly more complicated one. So the about build modal is quite a chunky component. You can see here, there's a lot going on here. It's still only got fairly minimal properties. It's got show, which is a Boolean, do we show the modal or not? And on modal dismissed, which is a callback function that's called when the modal is dismissed. Easy enough, but there's also one other thing, which is that this is not a pure component. It's getting some state. So it's getting config and from global configuration there. So there is some global state that can change what's rendered here. So we need to test that as well. So if we have a look at the tests I've got here, we've got 1, 2, 3, 4, 5 tests. And what they're testing, if we look at this one, for example, we should show the build number if it's different from the version number. So these are coming in through the global state. So we set up the global state there, and then we do a shallow render and we check that it matches the snapshot. And sorry, no, we check that matches the snapshot up here, but we're checking one specific thing here, which is that the version string takes this form when the config has that arrangement. And so what we have to do, each of these tests are covering the different kind of combinations of global state that change what's rendered in a way we care about. So we're testing to make sure it functions as intended by trying with different global state. We're also going to test the callback. So that's this test here. Should call on modal dismiss callback when the modal is hidden. So we set up the global state again just to make sure it renders okay. Then we make a function on hide, which we're going to use as the callback. And in it, we call done, which is for the test runner to know that we finished and it can consider this test case complete. So then we, much like before, but instead of shallow rendering, because we're going to actually need to access further into the tree of components here, we do a mount. And we pass in that function, and then we use this trick. So on the rendered wrapper, we can call find, and we can use that a bit like jQuery to find elements in the React component tree below there. So what I'm going to do here is find the modal. So inside the about build modal, there's a bootstrap modal component, and so I'm going to find that, and then I'm going to call on hide on it. So simulating as if you'd click the modal away in the browser, the bootstrap component gets an on hide. We don't worry about testing the bootstrap component because that's already taken care of by the React bootstrap. What we want to be sure is that when that on hide is triggered, our component does the right thing. And we expect it to call on modal dismissed. And if it does, we call done and the test case passes. So the thing to note here is we've got this function mount with intl. So the reason for that is because we use React internationalization in here. And in order for that to work, we need to inject the various bits and pieces into the components that are needed for that to work. So we have some helper functions over here, which basically do the same as shallow and mount would in Enzyme, just wrapping them with injecting the bits you need for English localization so that any strings that are localized render properly and it doesn't break due to not having them. The main thing I haven't covered here is testing events. So there is another way to do this. Here we've sort of manually simulated it, but what we could also do is instead of having this, we could call function on hide equals guest.fn. So that's, sorry, not function there, const. So that's a helper from the jest test runner that lets us, it sort of captures how it's called. And then we carry on passing that in there. And then rather than this, what we can do is we can, instead of calling into the props, we can do simulate hide. And what that's doing is it's simulating the event through the event system. And we might have for example, with a button that's being clicked, we might call simulate click or otherwise. And then what we can do is expect on hide, that's our sort of function monitor thing, to be called. So rather than having to mess about with the done and the callbacks ourselves, we can just say this, and that jest.fun captures what it's called with, and then we can check later that it was called the way we expected, and we can use in Enzyme this simulate to simulate events in the system. So with all of that, we've basically got everything we need to component test React components, because if you remember the props in the Redux framework, the props become the API, the contract that component's offering. And by testing that the right inputs get the right outputs and the right callbacks are called when the right events are triggered, we can verify that contract. And that's going to be really helpful if you want to modify a component or reuse it, because it avoids the problem that we often have at the moment, where you have to dig through the source code of many, many components within more components within more components to figure out exactly what's going on. And instead, it becomes a much more structured API. And that also helps a lot if you're looking to extend or replace any of these components. Okay, hope you've found that useful. That's it for this topic.